Hello everyone, I'm Runu Padidar, and in this presentation I will briefly explain the key points of foundation of 2D computer graphics, that is geometric transformation. So let's get started. So the first question is 2D, what are 2D transformation? Transformation is an operation that changes an object's position, size, orientation or shape on a 2D plane. In computer graphics, we apply these operations to every single point or vertex of a shape. Each point represented by coordinates x and y and is mathematically changed to a new set of coordinates, that is x dash and y dash. These are the fundamental building blocks for all 2D graphics, animations and UI design. Let's move to the next question. So, why do transformation matters? First is animation, moving a character across the screen, that is translation, making a character jump and spin, that is rotation, or making a cartoon squish and scratch, that is scaling. Second is game development, moving players, enemies, and the camera. Third is user interfaces, resizing a window, that is scaling, opening a menu, that is translation, or an icon, wobbling, that is rotation. And the last one is design and data. All vector graphics like Adobe Illustrator and data visualization, that is chart that zoom and pan, are built on these principles. So now move to the different types of transformation. First is translation. To move. The common definition for translation is it is the simplest transformation. It slides an object from one position to another along the straight line. And here is the formula. X dash is equals to x plus tx, y dash is equals to y plus ty. And how does it work? We add a translation vector to every point of the object. X subcoordinates is the distance to move along the x-axis, that is left to right, and y subcoordinates is the distance to move along the y-axis, that is up to down. The next transformation is scaling, to resize. Definition for scaling is it changes the size of an object by stretching or shrinking it from a fixed pivot point, usually the origin 0, 0. The formula for scaling is x dash is equals to x into sx and y dash is equals to y into sy. And how does it work? We multiply the coordinates of every point by scaling vector. And x subcoordinates scales the object's width and y subcoordinate scales the object's height. And the key point is if x subcoordinates and y subcoordinates are not equal, then the object's proportion will be distorted. Let's move to the next transformation, that is rotation, to turn. The common definition for rotation is turns an object around a fixed pivot point, by default the origin, by the specific angle theta. Formula for rotation about the origin is x dash is equals to x dot cos theta minus y dot sin theta, and y dash is equals to x dot sin theta plus y dot cos theta. And how does it work? A positive angle typically results in counterclockwise rotation and a negative angle results in the clockwise rotation. This is the most complex of the basic formulas as it uses trigonometry. Let's move to the next transformation, that is reflection, to mirror. The common definition for reflection is it creates a mirror image of an object by flipping it across a line of reflection. And how does it work? The common example is reflection across y-axis and reflection across x-axis. If we talk about y-axis, it flips the object horizontally. The x-coordinate of every point is inverted. That is x dash is equals to x and y dash is equals to y. X dash is equals to negative of x. if we are reflecting across the y-axis. And if we talk about reflection across x-axis, it flips the object vertically. The y-coordinate of the every point is inverted. X dash is equals to x and y dash is equals to negative of y. So here we face a problem, that is combining transformation. The problem is, what if you want to rotate an object around its own center, not the origin? You would have to translate the object to the origin, rotate the object, and translate the object back to its original position. So it is the problem. And the mathematical clash comes here is that translation is an addition, but scaling and rotation are multiplications. These two different type of math are difficult to combine into one single efficient operation. So this is the problem. So we have a professional solution for this. That is homogeneous coordinates. The trick, we represent our 2D points x and y as a 3D vector x, y and 1. This extra 1 is the homogeneous coordinate. And why we are using it? By doing this, we can now use 3 by 3 matrices for perform all transformation. This trick cleverly convert the addition of translation into a matrix multiplication, just like rotation and scaling. So the benefit is all transformation, that is translate, rotate, scale, etc. are now the same type of operation, that is matrix multiplication. We can combine a long series of action, example translate, rotate, scale, translate, into one single matrix. And this is the extremely efficient and is the standard method used in a modern graphic hardware, that is GPUs. So the summary of this presentation is transformations change the position, size or orientation of 2D shapes. Basic types are translation, rotation, scaling, reflection and sharing, etc. Professional methods are the professional method is homogeneous coordinates. Matrices are used to combine all operations for maximum efficiency. If you have any question, please comment below. Thank you for your attention.